Welcome to Calculus 1. Today we're going to talk about what we so-call the product rules and the quotient rules. And we're going to, at the end, I'm going to introduce something called the higher order derivative. Alright, product rule. These rules in this particular recording here is a little bit more complicated because I'm getting a little bit bigger now compared to some of the simple function that we had before. What is so-called the product rule is the product of two differentiable function f and g is itself differentiable. So if I had two functions being multiplied together and I want to take a derivative, what we will do is take a derivative of the first function times the second, then plus derivative of the second function times the first. Now if I had to take if I had to use a product rule more than just three variables, or more likely, like if I have more functions, okay. For example, if I have three different functions here, then I will take a derivative of the first times the other two, plus derivative of the second times the first and the third, plus derivative of the third times the first and the second. So if so in those cases, if I have to be involved with more than just two functions, we can just extend this rule a little bit further out. Now let's try some example here for the product rule. So let's say here I got my function f of x, 4x minus 2x squared times 4x plus 5. So this first one is like the f earlier. The 4x plus 5 is like the g earlier. Okay, the product of two functions. So to find the derivative, all I'm going to say is the derivative of the first. Okay, this is one is the first, and this is going to be, if I want to take derivative of this first one, do it just by looking at it. This is a difference of two functions again, so derivative of 4x is 4 minus derivative of 2x squared should be 4x, alright, times derivative of the first times the second, 4x plus 5. Alright, plus derivative of the second one. Derivative of the second one should just be 4. Using the power rule, derivative of a constant is 0. Derivative of 4x is just 4. Derivative of the second times the first, which is 4x minus 2x squared. Alright, now we'll simplify it. A little bit more work, so basically I'm using many other rules that we talked about in other recordings, just in this one alone. Okay. Alright, if I multiply this out, negative 4x times 4x is negative 16x squared. 4 times 5 is positive 20. This is this is 16x negative 20x, so that will give me negative 20 is 16, that will be negative 4x plus 4 times 4x, 16x minus ax squared. Alright, negative 16x squared minus ax squared, negative 24x squared. Negative 4 plus 16, positive 12x, and I still got my positive 20 here. Alright, so that's the answer. Okay, product rule. Alright, let's take a look at with the trig function here. So this one is, I want you to look at it as 2x times sine of x. Okay, product of 2x and sine of x. So go by the saying derivative of the first, so I'm viewing 2x as my first function. Derivative of the 2x will just be 2 times the second, which is just sine x, plus derivative of a second, derivative of sine x. Let me just make sure, derivative of a sine x, I believe is cosine x. So that would be cosine x. Derivative of a second times the first, which is still 2x. Alright, so I can factor a 2 at least. So that will give me 2 times just sine x, if I want to simplify it, plus x times cosine x. Alright, so I can leave my answer over here, or I can just factor out the 2. Alright, let's try another one. C. Alright, so let's take a look. This is the difference of two functions. So I will need to take a derivative of this function first. Now I'll take a derivative of the other one. So again, this is 2x times sine of x. So I'm gonna go ahead and say it again. I'm gonna say, looking at 2x as the first one, okay, looking at the sine x as the second one. So my derivative of the first is 2 times the second sine x, plus derivative of the second, which is cosine x, times the first. Alright, so that's derivative of this part minus, alright, this is the other function inside this one, so I can actually factor out the 2, the constant. So I'm just taking the derivative of the cosine x, which is negative sine x. So that will just be, so that negative sine x will make my negative become positive here. So that'll be 2 times sine x. Alright, let's see what can I do here. I do have like term to combine. 2 sine x plus 2 more sine x will make it 4 sine x. Alright, and I still got my 2x times cosine x. If I want to factor out a 2 here, I can, or I can just leave it right here if there's other things to do. Alright, that's product rule. Derivative of the first times the second, plus derivative of the second times the first. Alright, another rule is called the quotient rule. Quotient rule is actually takes a little bit more work while we're doing the simplifying. So here it says the quotient of f and g, f divided by g, of two differentiable functions, f and g, is itself differentiable at all value of x, for which g sub x in the denominator cannot equal to 0. So if I have a big fraction function that I need to divide and then take a derivative of, the way we say it is the derivative of the top times the bottom minus the derivative of the bottom times the top, and divided by the bottom will be squared. Alright, so a little bit more complicated here. So let's give us a try using quotient rule. Quotient rule is designed for a rational function. So by the rule, it said take the derivative of the top, which is 4x minus 2. So if I take a derivative, that would just simply be 4 times the bottom, x squared plus 1, minus the derivative of the bottom, which is just 2x times the top, over the denominator, or over the bottom squared. So that would be x squared plus 1 squared. So I'm using a lot of power rule here. using the difference of two functions rules. Okay, sum of difference rules. So from the previous recording, whatever those simple rules I introduced, you got to be able to do those just by looking at it. Alright, now comes the aggravating part, which is simplifying. So if I will multiply this out on the top, that's 4x squared plus 4 minus ax squared, negative 2x times negative 2, positive 4x. Alright, combine like terms for the top. x squared minus ax squared should be negative 4x squared plus 4x plus 4. Alright, over the x squared plus 1, whole thing squared. Now I know if I factor out the top, if I factor out a negative 4 for the top, that will leave me with x squared plus x plus 1. And there's no way I can factor this trinomial where it will cancel out with the denominator. So I don't have to continue because I can reduce the top with the bottom. So I will just leave my answer like that. Now this example will require me to kind of simplify it because I do have a fraction within the fraction. So let me clean this out a little bit. Let me rewrite this problem. Since the LCD is x between the top and the bottom, so I will multiply both top and bottom by x. Okay, so I'm trying to clean up this composite function here a little bit before I take a derivative. It'll make it a lot easier. 2x times 2 is 2x. Excuse me, x times 2 is 2x. X times 1 over x is just 1 over x times x, x squared. And x times 4, positive 4x. Alright, so I'm going to take a derivative of this thing here. Okay, that would be a lot easier. So let's try this again. Let me say this again. Alright, the quotient rule. Derivative of the top, which is 2, times the bottom. Minus the derivative of the bottom, which is 2x plus 4, times the top. Whole thing over the denominator over the bottom squared. Alright. Derivative of the top times the bottom minus derivative of the bottom times the top. So when I take a derivative of my bottom here, power rule, using power rule for the x squared, okay, derivative of a 4x will just be 4. Now let me simplify this numerator here. 2 times x squared, 2x squared, plus ax, minus 2x times 2x is 4x squared. Do a little bit for your method here. 4 times negative 1 is negative 4. My outer is 2x. My outer is negative 2x. My inner is positive ax, so that will give me positive 6x. Alright, whole thing over, denominator squared. And I'm just gonna subtract my up here just by looking at it. 2x squared minus 4x squared is negative 2x squared. Ax minus 6x is positive 2x. And negative 1 times negative 4 here makes that 4 a positive coming on a parenthesis, whole thing over. Okay. X squared plus 4x, whole thing squared. Alrighty, and there's the answer. Alright, that's quotient rule. Alright, let's do some other trigonometric function here. So we talked about this derivative of a sine and cosine function. So let's take a look at other ones. Derivative of a tangent is secant squared x. Derivative of a secant x is secant x times tangent x. Derivative of cotangent x is negative secant squared, cosecant squared x. And derivative of a cosecant x is negative cosecant times cotangent x. So you should see these on the formula sheet, so you don't necessarily have to memorize them. Okay, it should be on the formula sheet to help you out. Alright, so let's give a try. Okay, I'm going to leave this up here so we can kind of see it. Alright, difference of two functions here. So if I want to take a derivative of my 2x is 2. Derivative of a tangent is secant squared x, so that'll be minus secant squared x. And that's it. Now a lot of time when we're dealing with trigonometric function, you also got to notice the forms. The answer might actually in some kind of other forms where we can manipulate even some more. Okay, always watch out for that. But not this one. This is the answer. Alright, this is a product of two functions, so let me use product rule. So I'm going to view x and secant x separately. Alright, so product rule, derivative of the first, which is just going to be 1, derivative of my first, which is x, is 1, times the second, which is still secant x, plus derivative of the second. Derivative of secant is secant x plus tangent x. Secant x times tangent x. Derivative of the second times the first, which is x. Alright, since both terms has secant in it, I can factor out my secant. So that will leave me with just 1 plus x times tangent x. Now before we move on, let me go to the formula sheet. Let's take a look at it. On the formula sheet, one of the pages on trigonometry alone. So always need to look out for some of the double angle formulas here. Okay, power reducing formulas, sum to product formulas, product to sum formulas. We always gonna watch out for these, because if I end up with something like cosine of u, cosine of x times cosine of y, okay, I can actually manipulate, make them into look something like this. Okay, alright, Pythagorean theorem identities, got to watch out for those. Quotient identities. Okay, so we can do a little bit of manipulation when we're dealing with trigonometric function. Just look out for those. So if you ever run into a problem like this and all of a sudden your other math professor just whoop out something out of nowhere, that has a lot to do with these identities. Okay, that's in trig. Alright, doesn't happen all the time, but it can happen. It can happen. The whole purpose of it is to make you think even further. Okay, but not these. These answer, can't really do nothing with them. Alright, another objective here in this video is something called a higher order derivative. We talked about something called a position function and your velocity function before. It turns out we can actually obtain an acceleration function by differentiating the position function twice. So when I take a derivative of my position function, I get my velocity function, instantaneous velocity function. So if I would take a derivative twice on the position function, it will actually lead me to the acceleration function. Okay, so that means if I already have a velocity function or instantaneous velocity function, if I take derivative of that one more time, that will end up with acceleration. Okay. All right. So higher order derivative. That means we're going to take derivative 2 times, 3 times, 4 times. So for example, if I present you with this negative 0.81 t squared plus 2t, I want to find the second derivative. All right. So I'm going to use a simple notation. So f prime of x, so take derivative for the very first time. Power rule here, that will give me negative 1.62 times t plus derivative of 2t would just be 2. Alright. Take a derivative twice the second time. So this is the one I get after the first time. So now I'll take a derivative again. So derivative of negative 1.62t would just be negative 1.62. Derivative of a constant is 0. So this is the answer for the second derivative. Alright, called the higher order derivatives. Let's try another one. Alright, x squared plus 2x. So take a derivative for the first time. Derivative of x squared is 2x. Derivative of 2x is simply positive 2. Alright, take it the second time. Derivative of 2x is 2. Derivative of positive 2, constant, which is 0. So second derivative, my answer is 2. If I want to take it one more derivative, my third derivative, y triple prime, derivative of a constant would just be 0. Okay. Alright. Now let's go back and deal with this position function. So let's say if I present you with the position function negative 1/3 t to the third plus 30t, okay, in the interval between 0 to 6, where t is our time, find the velocity function and the acceleration function of the object when time is 3. So let's take a look at it. The velocity function. The velocity function will come from the derivative, okay, of my position function. So if I take a derivative of my position function, negative 1/3 t to the third, using power rule, 3 will come down, and that 3 times 1/3 will be negative 1. T, subtract the exponent by 1, that will be squared, plus derivative of 30t would just be 30. Alright, so that's my instantaneous velocity function now. So to obtain an acceleration function, okay, at a particular instance, okay, how much is the object accelerating? So that will represent position function. Take a derivative of twice. Alright, so looking at the one we just took the derivative of, negative t squared plus 30, move my exponent down, so that will give me negative 2t. Derivative of a constant will be 0. So this will be my acceleration function. So when the velocity is at 3 seconds, what's my instantaneous velocity at 3 seconds? So we plug it in, negative 3 squared plus 30. And that will give me positive 21 and I'm gonna since the object is in meters, okay, so there'll be 21 meter per second. Alright, so the instantaneous velocity at 3 seconds is 21 meters per second. Alright, so what is my acceleration at time 3 at 3 seconds? So we will plug in 3 into the acceleration function, so that will be -2 times 3, which is -6. Alright, meters per second squared. Okay, that's my acceleration function. So I'm actually not, since I got a negative accelerations, a lot of time that's probably referring to either I'm slowing down or I'm going or I'm free fall. Okay, it depends on what the object is doing. It doesn't say right here. Alright, so that's how higher order derivative is used. Okay, if I take a derivative twice, I get something called acceleration function. Okay. Alright, that will conclude this video. Thank you for watching.